Okay, number 9. So for number 9, they want us to perform function operations on f and g when f, okay, number 9. So for number 9, they want us to perform function operations on f and g when f is equal to 3x squared plus x plus 1 and g is equal to 3x. Okay, so let's start with f plus g. Wait, before we do that, they also want us to state the domain. So let's note that the domain of a polynomial is all real numbers, because we know that the domain is the set of all possible x values, and x can be any real number. And the domain of a rational function is all real numbers except for 0, because if we put 0 in the denominator of a function, the function will be undefined. And we know that the domain of the square root is all real non-negative numbers, because we cannot have a negative number in the square root of a radicand. Okay, so now that we have that noted, let's go ahead and start with f plus g. So f plus g is equal to 3x squared plus x plus 1. Okay, number 9. So for number 9, they want us to perform function operations on f and g when f is equal to 3x squared plus x plus 1 and g is equal to 3x. And they also want us, let me move g over just a second. Okay, number 9. So they want us to perform function operations on f and g when f is equal to 3x squared plus x plus 1 and g is equal to 3x. And they also want us to find the domain of each function. So since the domain is the set of all possible x values, let's note that the domain of a polynomial x squared is all real numbers, and that's for any polynomial, not just x squared, because x can be any real value. But the domain of the rational expression 1 over x is all real numbers except for 0. Because if we put a 0, if we set our denominator of a rational function equal to 0, it'll be undefined. So the domain of the square root is all real non-negative numbers, because we cannot have a negative number for the radicand of a square root. Okay, so let's start with f plus g. F plus g is going to be equal to 3x squared plus x plus 1 plus 3x. And we see that we have two x terms that we can combine. When we do that, since it's 1 and 3, 1 plus 3 is 4, we get 4x plus 1. Okay, and since this is a polynomial, we know that the domain is going to be all real numbers. Okay, and now for f minus g, it's going to be 3x squared plus x plus 1 minus 3x. And we have two x terms we can combine, 1 and negative 3. 1 minus 3 is negative 2. So we have 3x squared minus 2x plus 1. And since this is another polynomial, the domain is all real numbers. Okay, so what about f times g? F times g is 3x squared plus x plus 1 times 3x. And for this one, we'll just distribute 3x throughout 3x squared plus x plus 1. And when we do that, we get 9x cubed plus 3x squared plus 3x. And since this is another polynomial, the domain is going to be equal to all real numbers again. Now let's move on to finding f divided by g. So f divided by g is 3x squared plus x plus 1 divided by 3x. And we see that there's nothing we can do to simplify this. And we can also see that our only restriction is that our denominator cannot be equal to 0. And so if we solve this expression for x, we get x cannot be equal to 0 by dividing 3 on each side. So if we graph that expression on a number line that goes from negative infinity to infinity, we can express our domain in interval notation. So we'll just plot 0 with an open circle and shade everything that can be included. And from there we see that our domain lies on the interval that goes from negative infinity to 0. Forgot to say that that's 0. And from 0 to infinity.